Hello dear students, here is a GeoGebra representation in order to understand the idea of the principal value. Now, as you know, the principal value of the measurement of an angle is usually included between minus 180 degrees and 180 degrees, as well as minus pi in radians and pi radians. Now, here is an angle whose measure is 60 degrees. Surely this angle, the measurement of this angle is a principal value because it's less than 180. Now, let's see what about other angles related to this angle. For example, if I have an angle whose measurement is 420 degrees. Actually, 420 degrees is equal to 60 degrees plus 360 degrees. That's corresponding to pi over 3 plus 2 pi. So as you know, 360 degrees is corresponding to 2 pi and 60 degrees is corresponding to pi over 3 in radians. So 420 degrees, as if I'm moving 360 degrees starting in the positive sense from 0 till 2 pi, which is equivalent to 360 degrees. So I'm again at 0. So as if I moved nothing. And what remains is just plus 60. So what I see is only the end of the arc, the end point of the arc. So that's confounded with the end point of the arc whose measurement is 60 as well. So that's what we mean by the principal value. So again, 420 degrees is not a principal value because it's a very large angle. It's larger than 180. I can decompose it into 60 plus 360. 360 degrees is confounded with 0 because it represents a complete turn starting in the positive direction from 0 till here, and the remaining part, which is definitely less than 180, is called the principal value of 420. Let's make sure and plot this angle using angle with a given size. I'm going to plot the angle whose measurement is 420. I write here 420 and okay. Then as you see, the end point of the new arc is A1 prime. It's confounded with M. Similarly for 780, which is actually equals to 720 plus 60. Again, 720 is a multiple of 360. It is 4 pi. What does 4 pi mean? 4 pi means as if I'm moving from 0 till 2 pi one time, then another time from 0 till 2 pi. This is how I move 4 pi. So 60 is corresponding to pi over 3 and 720 is corresponding to 4 pi in radians. So 4 pi means as if I'm moving 2 turns and returning to 0 again, and the remaining only is 60. That's what's going to appear when I plot the angle whose measurement is 780. And let's make sure again, angle with given size, I choose this starting point, this center, and I write the given measurement, which is 780, and see, I will get the end point, the third end point, exactly A3 prime is confounded with M and is confounded with A1 prime as well. So the three endpoints are confounded. That means that 420, 780, and 60 are actually appearing in the same place. Their endpoints is actually appearing in the same place. Now, let's move to another angle whose measurement is 150. So as you see, this is an angle whose measurement is 150. Definitely 150 is less than 180, then it is definitely a principal value. Now, if I talk about the angle whose measurement is 1230, notice that 1230 is equal to 150, the angle plotted, plus 1080. 1080 is corresponding to 6 pi in radians. 6 times 180, if we substitute pi by 180, we will get 1080. What does 6 pi means? 6 pi means that I'm moving 3 turns. So the first turn is 2 pi, the second complete turn is 4 pi, and the third complete turn is 6 pi. So any even number multiplied by pi will return me to 0 definitely. That's why I cancel the even number multiplied with pi, which is corresponding to this value in degrees, and the remaining represents the principal value. So 150 degrees is the principal value of 1230 degrees. Similarly for this one, which is 1950, it's definitely equal to 150 plus 1800. 1800 is actually 10 times pi if I substitute 180 in place of pi. So an even number multiplied by pi here means that I'm going back to 0. What does 10 pi mean? 10 pi means that I'm moving 5 complete turns. Each turn is 2 pi. So actually I'm returning back to 0, and the remaining part, which is 150, is the principal value of 1950. So in general, if I have an angle written as follows, for example, theta equals 445 degrees plus 2k pi. 2k pi usually represents an even number multiplied by pi. So every even number multiplied by pi is corresponding to 0 as well. Okay? So if I have 45, and here is a slider that's going to move k from -5 till 5. K is an integer indeed. So I'm moving k, notice. However I move k, the angle is still in its place. Let's make it clearer. Here is the angle corresponding to 45. Okay. Let's delete this one. Okay. So here is the angle corresponding to 45. Okay, so however I move k, the angle, the endpoint doesn't change. And that's a simple representation of the principal value of an angle.